It's a pleasure for me to welcome Scott Michael today to our what I think is going to be probably the sixth of these sessions. Scott is a close collaborator of CTSI Informatics, which is one of the organizations hosting the series. He's the director of research software and solutions in the research technologies division of UITS, University Information Technology Services. He is a IU Bloomington alum with a PhD in astrophysics and has worked within research technologies in a variety of roles, supporting research programs in astronomy, all the way from astronomy to quantum chemistry. He works a lot on performance optimization, workflow scalability, and systems level operational efficiencies. He's worked in the AI space since 2018 and when he began leading the research applications and deep learning team. So with that, let's welcome Scott. Thank you, Scott, for doing this, and it's all yours.
Thanks, Titus. This is, I have to say a little bit, I do most of my presentations in person, so I'm getting flashbacks to the pandemic, which is, not a great place, I guess. Hopefully it's not too soon, but, and thanks to everyone who I see here online. I see a lot of you are folks that I don't know or I'm not familiar with. So I want to give you just a brief overview of myself and add a little bit to the introduction that Titus gave. If you have any questions throughout the presentation, please feel free to either drop something in the chat, I have it up here, or just unmute and ask your question, and I'll be happy to address those as we go through. This is the first of a 4-talk series that's focused on AI techniques and generative AI tools that we have here at Indiana University for research. This first talk is really going to focus on giving an overview of what are some of the sort of fundamentals of AI in research, what are the underpinnings of some of these tools that you may be familiar with or be using in your research. The next talk is really going to focus on the breadth of tools that we have across the university through partnerships and contracts, things like Gemini, ChatGPT, Copilot. The third talk will be more focused on research-specific tooling that we have either developed or host here at the university. And then the last talk is going to have a big emphasis on practical use cases and give some real workflows and things like that. So I am, as Titus mentioned, a theoretical astrophysicist. My research focuses in simulation and modeling. That was what I did my PhD work on. And from there, I moved into the research technologies division here at UITS, where I've been focusing for the past decade or so on performance optimization and scalability. I've gone through a variety of roles here, and I'm now the director of the Research Software and Solutions Directorate. We focus mostly on user support, software, open source software on our HPC systems. Some of the services that I'll mention today, our LLM service and our transcription service. And then we also manage the university's RedCap instance and provide all of the support for that. I am not and have never claimed to be a fundamental AI researcher like a computer scientist. I'm also not a clinical researcher. So we really focus on the tools here and what we can provide to the folks doing the research and help empower you to be able to be more effective at your research. So this is not the sort of end all and be all on fundamental AI research. I always like to throw this up. It's overview slide of the Research Technologies Division. We have 4 different directorates, and there, as you can see, there's a lot of folks here that are all working to support, the various different services and cyber infrastructure that goes into supporting research at the university. So if ever you have a question or a problem with any of these areas, certainly you can always reach out to me or to any of these other directors. Okay, so today like I said, I'm gonna talk more fundamentally about what does it mean to be using AI in research? What are some sort of research workflows and places that you may be able to or may already have plugged AI tools into your research workflow, and then specifically going to be focusing in on sort of LLMs and their place in research. And then we'll talk a little bit about how to design your, the possibilities for designing your own models and deploying those, or leveraging the services that we have here already at IU. So just to start off, I like to start by defining a few terms. AI, generally, when I'm referring to it here, is really a constellation of techniques and tools. And this is sort of the Wikipedia definition, where it is, a capability for a computational system to behave like a human. So there's a whole host of different techniques that can fall under AI, from sort of business intelligence, automation, sort of traditional machine learning, neural networks, and then, people talk about artificial general intelligence, which is something that is, on the horizon. But generally speaking, this sort of nested diagram here, where artificial intelligence is a whole host of different techniques, with machine learning being a subset of that, and deep learning or neural networks and LLMs being an even further subset of machine learning, is the sort of mental model that I like to go with. So when we're talking about deep learning, machine learning, LLMs, and other AI things, it's also important to sort of define what those are. There's a lot of different types of machine learning algorithms, and these are algorithms that you can be trained on a large amount of data, and can sort of differentiate or help select important features in a given data set. And as we're looking at sort of all of the different AI techniques on the right, really this talk is focused in on deep learning, but I want to make sure to mention some of these other types of algorithms as well. So probably a lot of you have used things like regression or random forests. The sort of new interesting stuff is all deep learning and neural networks, which is what underpins sort of large language models. So deep learning is this particular type of machine learning that uses these neural networks, and then produces some interesting output based on that. So the sort of overview, and I'm sure you've seen a graph like this before, of what is a neural network, and this is an example of a fully connected neural network. Is on the right-hand side, you provide a series of inputs, and then on the left-hand side, there'll be something that comes out, in a classification, a response, and each one of these neurons in this diagram represents a node that has a certain activation weight and a bias towards the subsequent layer. So by feeding different types of inputs into the left-hand side, you can get different results. There's many different types of network architectures. There's different types of neurons that can be used in those networks. And they all start sort of at a randomized value and then are trained on data that has a known set of inputs and the results that you want. And this is what we call supervised learning. So this is just sort of, as of a few years ago, sampling of of many different types of network architectures. And LLMs use something called a transformer architecture, which is, the takeaway here is that all of these architectures operate in largely the same way, in that they need a large amount of training data to determine the sort of model weights, and then you can use that. Once the model's been trained, you can use it to infer results from new inputs. So before, long ago in the late aughts, the cutting edge application of neural networks was in the vision space, and was sort of classifying images. And so this is a fairly well-studied and well-solved problem. So image recognition was one of the first use cases. This is something from several years ago. And you can today take any sort of pre-trained network and put in images, and it will be able to classify with a very high degree of accuracy. But depending on what your specific inputs and classifications are, you may need to do some specialized training. So it's easy enough to, for example, classify Johnny Depp with a shipwreck here. But if you're doing something much more specific or precise with medical imaging, where there's not nearly as much training data that's been used, you may need to do some training for your own particular use case. It is also worth noting that even the best of models can be fooled, and no model is perfect. So we see here that this is a classification of the same sort of ImageNet classifier, which very accurately predicts that this is a meerkat. And then when you add some random noise to it, it thinks the meerkat is now a doormat. And so it's just a reminder that no matter how capable or good the model might be, there's always the chance of sort of what's called hallucination in an LLM sense, but inaccuracies and errors. And so it's always a good idea to be reevaluating the accuracy of the model predictions as often as you can. So I'm getting a little bit of feedback. Yeah, okay. So like I was saying, one of the first applications that was widely used was image classification. But then when we come to generative AI, that is a set of models that are built upon a neural network that's arranged around this transformer architecture. And ChatGPT first came on the scene in sort of late 2022, and everything's been sort of exploding from there. Um, what a transformer model is a sort of new way to look at text and a language model, and it changed sort of the way that the neural network models have been used to be able to predict text based on an input. And basically, this is the standard architecture now for any of the many LLMs that you see both commercially and available as an open source offering. And so this sort of gives you the history of the evolution of transformer models or of LLM models. And you can see that in the last few years, the number of entries has sort of ballooned compared to prior to 2020, 2021 or 2022. So transformer models are not just good for text alone, but they can also do things like image classification, or they can use in conjunction with image classification models to do text plus images, text plus audio, text plus video, and things like transcription. So we've seen a lot of new releases of LLM models and a lot of new capabilities that have come out within the past just year or two. It's really interesting to me. This is from a talk that I gave back in 2019 about AI and largely focused around image classification, and it's sort of the traditional hype cycle. And at that point in time in 2019, I said, you know, we're here at the peak of hype. And then since then, obviously, LLMs have become a big thing. And as of 2025, Gartner's hype cycle puts us again at the peak of hype. Um, the interesting thing here to me is that many um, of these technologies, there is a less than 2 year time horizon to get into the plateau of productivity, and the rest of them are in sort of a 2 to 5 year time horizon, except for AGI, which is more than 10 years. So all of this stuff is still relatively new, but the expectation is that it will become sort of standard fare pretty quickly. And so the question then becomes, how to incorporate these things into your research workflow and make the best use out of them, and what are some caveats or things to be aware of as you're doing that. So this is from a talk that my colleague Ann Leftwich in our Learning Technologies division gives quite often, that sort of outlines several different stages in a research workflow, from the sort of ideation phase to the data collection or beginning of your experiment phase, through the data analysis and publication phases, and then sort of touching on your ethics and responsibility and how to best collaborate with multiple institutions or other research groups. And so at each phase in this research workflow, there is opportunity to use different types of LLM tools in different ways. And certainly, I don't want to be sort of prescriptive and like these are the only ways to use these tools, or these are the best ways to use them. But these are just a few ideas of how you might think about deploying or leveraging the different tools that are available to you here at the university. So in the ideation phase, having a conversation with a chatbot like a ChatGPT or a Gemini can be quite useful in sort of fleshing out ideas, asking questions, especially since most of these tools can or are already web search enabled, and so they can pull in data from various different publications or other uh, items of interest on the web. You may have access to, works or papers that are not easily accessible or publicly available on the web. So you can also use a chatbot interface to sort of upload the papers of interest that you want to either have summarized or to bring out or ask questions of about a particular point. There's also a feature on many of the tools like Gemini and ChatGPT called deep research, where the implementation is different depending on which tool you're using, but basically the backend will deploy different agents that will act as researchers and will go and sort of pull in papers or data to try and answer a much more sort of in-depth question and provide a much more detailed report than might just come out of the one-off chat. So, in that sort of initial phase of maybe experimentation design or just ideation, I think a lot of the best use cases are around that chat interface. As you move on to collecting data, there's a lot of tools. You may be collecting interview data, video data, audio data that needs transcription. So there's a lot of AI power tools that can assist in that. I I've worked with researchers that have created their own chatbot that is designed as according to the experimental protocol to collect data or to be conducting the experiment. You can also use tools to do sort of large scale data cleaning or summarization. The summarization piece is particularly useful if you have a lot of unstructured sort of free form, be it notes or survey responses or something of that nature. And depending on your type of experiment, you may have you may be running simulations or you may be doing a bunch of analysis. There are a number of tools that are AI accelerated that can either steer simulations or do accelerated modeling. And then as you're into the sort of writing a publication phase, one thing that a lot of people use AI tools for is citation management. And then, once you have a manuscript, it becomes very straightforward to create a talk, a PowerPoint, a press release, other sort of auxiliary materials to distribute using these AI tools. As we're talking about like interacting with LLMs for research, there's I like to classify there's three basic methods or ways that you can interact with an LLM service. The first is the chat interface, and I'm pretty sure everyone's familiar with this, but just in case you're not, let's see. This is the Realms chat interface that we run here on premise at IU. I hope everyone can see that. I think it's sharing. So we have multiple different models available. You can choose whichever one you like. Let's do the ChatGPT one. And then, you can ask a question. Why is the sky blue? And it will quickly answer that question. You can also do things like upload documents and then ask questions specifically about those documents, or give it a particular web page to talk about or to ask questions about. So, I mean, that's a pretty standard chat interface. Also, there's the Gemini and ChatGPT interfaces here at IU. The next one is the sort of API. And this one you may or may not have had experience with. So this is just a sort of terminal window. So the Realm service also runs an API, and you can write code against that API. And this is just a simple command here where we're looking at the endpoint for realms. You need to have a API key, which I've defined here, and then you can ask a question or you can feed in whatever. If you have a web application, you could be providing questions that are coming from people that you're collecting data from, or it could be some other data source that you're trying to analyze. And so this question will go to the API endpoint when we run this command, and it'll take a second, and we'll get the sort of fully formed answer back here. A few things that you'll see when this comes up. Actually, let me see if I can. It's a little bit bigger. There's a whole long answer here, which is what you would have seen in the chat window. There's also sort of a bunch of key value pairs here that tell you what to help you identify your request, and it gives you some tells you how many tokens you used, and there's a number of other things you can sort of request through the API, things like a confidence score, and other items there. So that's how sort of the API works. It's really designed for putting into either a web service or some other interface that you might be using, where you need to have access to the LLM on a ongoing basis, where you don't necessarily know exactly when the requests will be coming in, similar to a chat interface, but you need more programmatic access. And then the third way of interacting is through batch processing. So here you might have a huge amount of documents or data that you need to process. You want to use an LLM approach, but it's in a very structured way, and it comes sort of at a large scale at a well-defined time. So for that, we have the option of using our HPC systems here. We have two currently in operation, Bigger 200 and Quartz.
Scott, one small interruption.
Sure.
Sean had a question about using critical data, PHI, with any of those three modes that you just talked about. And then Sarah, we'll take your question at the end.
So yeah, that's a great question, Sean. The mode, so each one of the sort of services that we'll be talking about in the series all have both chat interfaces and API interfaces. I'll say off the top that the only service that's approved for critical and EPHI data is the on-premise service that we run here called Realms. And it provides both the chat, that was the chat interface, and the API interface that I showed just now. The other options, like Google Gemini or ChatGPT EDU, are not currently approved for critical data. They both have the sort of, you can access for free or through the university contract the chat interface. They both have API access as well, but that is a you need to set that up as a separate account, and there is some cost associated with it. And so it really, you need to sort of see what your use case is. And so I do know some workflows that sort of have been approved by the data stewards. I don't think any of them have EPHI in them, but they're sort of working towards that. Did that answer the question? Or if there's any follow-up, let me know. Right. So the batch way is by using our supercomputers. So okay, those methods though basically allow you to access the LLMs as they exist, and each one of the different models. So like whether you love Claude and hate Gemini, or ChatGPT is your favorite, all have a slightly different, although they have the same underlying transformer architecture, they have different characteristics based on things like model size. There is, for the commercial offerings, a bunch of sort of pre-filtering and context that's added when you submit something into their chat. And so those different models may or may not sort of produce the kind of results that you're really looking for. If they don't, there's a number of ways to augment those models, or create a model basically from scratch to do whatever it is you need to in your research workflow. So the first thing to start off with is, do you want to take an already existing model and modify it somehow to your particular use, or do you want to create sort of a model from scratch? So going back to image classification, if you're specifically working with medical imaging and the image classifiers that are out there are based around, cell phone pictures or whatever, and can tell you the difference between a stoplight and a dog, but have no idea the difference between, a spleen and a liver, you may want to start from scratch, particularly if the type of imaging that is of interest to you is not one that, is a type of instrument or a type of imaging that's not widely available, and there hasn't been a model already pre-trained. The challenge always is that to get a really highly accurate model, you requires a lot of training data, and particularly if you want very specific or very nuanced classifications. So you need to have a huge amount of data in order to be able to train a model from scratch. But it is certainly possible. If you don't, if you don't need that level of specificity, or if you don't have enough data to train a model from scratch, you can do a number of other things with already pre-existing models. For LLMs specifically, there is the whole idea of prompt engineering. So the way that an LLM works is, as you saw for the API, we sort of sent this question as a payload to the API, and it responded. The same thing's happening on the back end when you're chatting with it. But in both of those cases, you can modify that that question with some context that can be, specific to the way that you're delivering it. If you're delivering it to your own website, you may have asked the participant some questions ahead of time, and you may want to provide that information to the model. Or you might just always want the model to behave in a particular way. And so you can add that context into the prompt, and it isn't visible necessarily to the people, to whoever is interacting with the LLM. You can also put guardrails on sort of the types of responses that you'll allow, or the types of inputs that you will allow to go into the LLM. So that's like the first and easiest way to modify an LLM. And so here's an example of the Kelly School has taken the Chat GPT, or the GPT open source GPT model that I showed you with Realms, and takes teacher evaluations, which they do as sort of a separate process from the sort of standard evaluations, and takes all of that data to provide it back to the instructor in this sort of well-formatted and nicely sourced document. This is all done basically with prompt engineering and sort of guardrails. So there's no changes to the model. They're using the sort of the standard ChatGPT model. It hasn't been fine-tuned, and they are bringing in some the scores, but it's not really retrieval augmented, which we'll talk about in a second. So the next thing you can do potentially is to fine-tune the model. So the sort of standard LLMs are quite large. They have anywhere from tens to hundreds of billions of parameters. So each of those sort of neurons, there are 100 billion in many cases neurons in a given LLM. It may be that in order to sort of provide specific answers, or hone in on the data that you're most interested in, you can replace just small portions of that model, and that then the results that you get will be much more in line with what your expectation is. And so this is sort of a schematic of how that works. You take a model that's already been trained, which is the base model here. It's been trained on a huge amount of data. And then you add your own very specific data to modify certain layers of the model. Typically, you're modifying the last few layers to give out a fine-tuned model. So there's pros and cons, which I'll go over in a second, between fine-tuning and then retrieval augmented generation, or RAG. In RAG, you don't actually change the model, but you provide some additional context to your query. So someone can ask a question. You have curated some data that's going to contextualize that question in a separate data store. And before the question is sent to the model, a search is done on that data store, and all of the relevant context, all of the context that's relevant to the question, is returned and provided as context to that question that's sent then to the LLM. And so here the model itself stays the same, but the context is being changed based on the input question. So each one of these techniques, fine tuning and RAG, produces a sort of more specialized and more detailed result from the LLM, but they each have sort of trade-offs. Fine tuning ultimately allows you to be a little more precise and specific than RAG, and it allows you to also change the model. So another thing I should have mentioned is that when you have a model with 100 plus billion parameters, it's actually quite large in terms of the size of the just the model itself. And the way that these models are run are typically on GPUs. The more parameters, the more of the GPU's memory the model takes up just to be there and running. And so the more resources are required to run that model. Um, so the smaller you can make the model without sacrificing accuracy, the more efficient more efficiently you can run and on the sort of smaller hardware footprint, and it's less costly to run that model. So fine tuning allows a way to sort of shrink models potentially. Um, the model itself is sort of self-contained. It doesn't require the connection to that external data source. On the other hand, a downside is that you can't very easily update that model. And so you would have to go back and do another round of fine tuning and training in order to make changes to the model. And the training stage, although you might come up with a smaller model such that the inference was cheaper, the training can be quite costly. For RAG, there is no real training cost. You're just using a model that's already been trained. You can update the sort of results that you're going to get by simply updating that data store and providing either a different or more context. However, that data store is another piece of sort of infrastructure that's required, and you need to tune it separately from tuning the model, so that the search and retrieval is producing the type of context and results that you would want to see. Also, the context that's coming along from that search can be quite large, and these models are limited by the amount of input data that they can take, as well as the amount of data that they can send out. You may have experienced this if you run a very long chat in a Gemini or a Chat GPT. The entire breadth or length of the chat is used as context, so that the model continues to update its answers as that goes on and is fed back into your subsequent queries. It's continuing to use more and more of the context window. Well, and you may run out of context window. In the same way, by putting a lot of context from a retrieval into the window, you can run out of space. So at the very end here, I'll say just a couple of things about the data sensitivity, and this gets a little bit back to Sean's question, and then I'll talk real quickly about federated learning, which is super interesting, and I'd be happy to talk more about it, but it might not apply to a ton of people, so I only just put one slide in here for it. So at the university, there are these different data classifications. There's public data. Basically, this is data that anyone can access and you can just get from the web. Any public data is fine to go through any of the tools that you have access to at the university. There's university internal. Probably most of the stuff for research is not going to be university internal. Most of the research data is either going to be restricted or critical data. And critical, a lot of it is going to be critical data. So anything that has personally identifiable information, that means like an audio recording, a video recording, or patient records, anything like that, basically falls under the critical category. And the only LLM type service that we have today that you can put critical data into is the Realm service. Oh, I'm sorry, and Microsoft 365 Copilot. So Copilot and Realms. There is a small caveat though with Copilot, which is that the data, the critical data that you're using with Copilot needs to be in a Teams share that is appropriately marked as having critical data, so that that data is not shared or leaked through Microsoft. And obviously, if it's okay for critical data, then it is okay for the less restricted classifications as well.
Can I ask? Can I clarify? So, yeah, the term critical data, I thought critical data and PII, PHI were two different things. Is that true?
That is, they are different. ePHI and PII are a subset of critical data.
Okay, so that's included in there. So yeah. I can copy a patient's clinical chart into the realms.rescloud.iu.edu chatbot without any problem.
Yeah, as long as it's coming from a secured system, yes.
Okay, perfect. Thank you. And the same goes for the API?
Yes.
Okay.
I got a follow-up question, Scott. So you said if the critical data are in a secure team space, then Copilot automatically knows not to use them to augment its own model. Did I get that correctly?
Yes.
All right.
If it is appropriately labeled as critical, yes.
All righty. But it would be that by virtue of being in a secure Teams workspace.
Right.
Right. Okay. And then the other question is, for pretty much, I think all these models, you can switch off the flag that uses your input to improve the model. I forget what it's called. It has like different permutations across Gemini and Copilot. So if I switch that off, meaning Copilot will not keep a chat history of me, for instance, and it'll also not use my input to augment its model. That means also my data don't go there, and we still, they stay on our side.
So not quite. There is a distinction between those two things. One is is your data being used to refine the model? And for all of the services that we have a contract with, if you're using the IU branded Gemini or the IU ChatGPT, you don't need to toggle anything. None of your data will be used to improve those models. That's part of our sort of contract. However, your data still goes to OpenAI or goes to Google for processing. You're sending that into their data center, and the security team or the review has not yet concluded that there's enough sort of either contractual or physical cybersecurity in place to be safe to put that data into that that interface. Does that make sense?
Yeah, that does make sense.
Any other questions? So when there's a whole bunch of different, if you have a question about like what type of data what is the classification of my data, the website is datamanagement.iu.edu. There are tons and tons of different examples. There's also the data stewards who are happy to consult with you on any specific data questions or research workflows that you might have if you have concerns about, what tools are appropriate and how you might be able to share or not share your data. If you we were talking about training models and you want to train a specific model using clinical images, one challenge that people often encounter is the sharing of data. So you might have a data set of images, and you may have a collaborator or another institution that uses using the same type of instrument, and it also has a large collection of images. How could you put your resources together to train a better model? Because, as I said earlier, the accuracy really depends on the amount of data that you have, and often that is the limiting factor for how good the model can be, is how much data you were able to bring to train it. And that's where we come to the idea of federated learning. And so the way that this works is that there is an amount of training that is done locally to create a set of weights. Those weights are created in a way that is non information preserving. In other words, you can't reclaim the data from the weights themselves. And then they're able to be combined together into a larger model to create a more accurate and sort of better model in this federated way. And so there's been a number of, this is sort of still an active area of research in terms of how possible or not it is to reclaim any of that or recall any of the training data that went into those federated models. But there are certainly ways to do this in a safe and secure manner. And there's been several sort of use cases that have shown that it's a useful way to really improve model accuracy. So certainly something that is interesting if you are looking to collaborate across institutions. And so I think that's pretty much all I had to say with that. I'll sort of wrap up and ask if there's any questions.
Yeah, thanks, Scott. That was great. There's a couple of more questions, mostly about access. And I actually was wondering about similar items. For instance, I think what Liz is asking, like, when can you be sure that you're using the university hosted version of Gemini or Microsoft 365? For instance, my question is, do I have to be on the VPN, or if I, use it from home, then obviously I wouldn't be on the VPN if I don't switch it on. So maybe you can explain that a little bit more. And Mark had a great suggestion about, kind of a flow chart to a decision tree, so to speak, to know what goes where under what conditions. So I'll let you answer that.
Yeah. So there is although it's not a flow chart, there is a pretty comprehensive KB document that lists out each of these tools and what data classification is okay to use for each of them. So I'll send that, or I'll put it in the slides before I send them on so that you can look at those there. In terms of how to be sure that you're using the sort of IU version, everything is tied to your IU email address. So if you log into Google or are using Gemini using your @iu.edu email address, then you're in our tenant, and all of the sort of contractual and actual safeguards are in effect. Same thing with Microsoft. For ChatGPT, that is an opt-in, and you have to go sign up for it. Once you do, it will convert. If you had signed up for ChatGPT and paid or had the free version with your IU email address, it'll convert that account into the IU tenant. And so from that point forward, using your IU email address, it will be under the sort of IU protections.
Okay, that makes sense. So basically, use your email address to log into these services. Your
Yes.
IU email address. Yeah, I'm thinking about, at home, obviously most likely or most often my Gemini account will be my Gmail account or my Google account because that's what I'm logged in anyway.
Right.
So I will have to log out of that and log in with my IU account to get to the IU hosted version of it. Okay.
And it's usually better, I will say. So I often have this where I'm on the Gmail and then I switch to the IU one because the capabilities are so much better. So
yeah. Cool. Other questions? We got 3 minutes.
Can I say something? Are we allowed to talk verbally?
Go ahead. You can talk. Yeah.
I'm still not sure I got across my point. It needs to be simple, like I'm explaining it to my grandmother, okay? Or someone, okay? We need a simple chart because people aren't, I'm afraid they're not going to know, oh, I got to choose this account. I log in with this. I'm on VPN. Totally will lose a lot of people. And I think we need a very simple flowchart, like use this for this, this for this, this for this. Here's the hot link, and here's what you do. One slide or whatever you can boil it down to. I really think if you make it simple, more people will be in compliance. I'm just worried. Thanks. The rest of this was great, by the way. I loved it, but I just really think you have to make it simple.
Yeah, thanks. I really appreciate that feedback, and I will say it is one of our great challenges here at UITS, making things simple. We unfortunately like to offer you every possible choice under the sun and leave it to you to figure out which one's best for you. And so it is something that we struggle with, but we'll do our best on this one going forward.
Yes, it certainly is a tension between those two things. I mean, you have a lot of complicated tools, but that is the challenge of design, designing something to be approachable. So I completely get the difficulty there. Okay, maybe one other question if we have time. Going once, going twice, going 3 times. Well, thank you, Scott. We'll have you back, for the other 3 workshops you briefly outlined. But I agree with Mark. This was like a lot of information, to some degree very technical, but I mean, you are the technologist, so nothing wrong there. But it was great to kind of have this more technical deep dive, and especially understanding the services as UITS provides them. You are really our first speaker from UITS, and fortunately you're going to be back. So last question from Minatala. Yes, all these sessions are recorded. We actually have a complete archive of everything we've had in this series, and we will email that out again as a reminder after, like with the slides, pointed to the slides, and the recording from Scott. We'll email that out. And Zach, we should also make sure this is in in all the invitations, so people don't need to look for email, like all the appointments, pointed to the page with the recordings. But it's great to have speakers like you, Scott, and thanks for putting this together, and we'll welcome you back in a few weeks.
Great. Thanks.
All right. See you guys. Bye.